Hello and welcome to Common Core Geometry by eMATHinstruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson Number 2, Lines, Rays, and Angles. Now in these introductory lessons on Common Core Geometry, we're going to be trying to build up the tools that you'll need to do more challenging work later on. Last lesson we looked at points and distances and segments. In this lesson we'll look at related topics of lines, rays, and angles. So let's get right into it. All right, let's first talk about what a line is. Okay, let me read off its definition. A line is an infinite set of points that extends forever in two directions. Since lines are uniquely determined by any 2 points on the line, we symbolize them by a double arrow over 2 points. So in this one example, what I've got is A, B, those are 2 points, with that arrow that goes both directions. Sometimes they're referred to by lowercase letters such as L, M, and N, and we'll see both of them quite often. Remember, if that double arrow is not over the 2 letters, then technically we're talking about the distance of a line segment, the length of the line segment between point A and B. When we've got the double arrow over it, that means we're talking about an infinitely long line. In fact, let's take a look at this in a little GeoGebra widget. All right? If I simply, within this, plot a point, okay, and plot another point, those 2 points are going to uniquely determine a line. In fact, let me draw that line in. I'm going to choose my line, choose point A, and choose point B, and notice now what happens, right? We have this line that extends infinitely in 2 directions, okay, based on just 2 points. And I can move those 2 points around, or I can draw maybe another completely random line. And that's kind of nice too. But if I move that second point, B, or even that third point, C, right, then what I'm getting are these lines, these collections of an infinite number of points that go on forever in 2 directions. Now, that's a line, right? And again, a line is symbolized by those double letters, double capital letters, with the double-ended arrow on both ends. On the other hand, let's talk about what a ray is. Rays are very, very similar to lines, right? A ray is an infinite set of points that extends forever in one direction, just one direction, from a starting point. Like lines, rays are symbolized by using 2 points, but only a single arrow, right? And we kind of obscured this a little bit here, but there's that point with the single letter. Let me get rid of this just for a second. All right, there it is. Let's take a look at a ray down here. Here we go. Again, in order to draw a ray, what I need are 2 points, right? I need a starting point, like point A, and then I need some point that kind of shows the direction of the ray. So we'll take point B. But now if I ask my program to draw a ray, right, and I started at A and go on to B, then what we notice is that the collection of points is only going in one direction, only going in that direction, all right? And if I move then point B around, right, B is really just sort of setting the direction of the ray. A is telling us where it starts. That second point then tells us the direction of the ray. And again, important distinction. There's really 4 things now that could be a little bit confusing, right? You've got a line segment with a single bar, no arrows. You've got a line, same thing, 2 letters, but then a double arrow. And then you've got a ray, right? Same thing, 2 letters, but a single-ended arrow. And finally, to make matters even more confusing, you've also got just the single 2 letters, you've got the 2 letters that have nothing above them whatsoever. And keep in mind when you have that, when you've got this situation, again, what this means is that the length of the line segment between point A and point B, literally a length, all right? Okay. Wow, we haven't even done an exercise yet. Let's jump into exercise number 1. Exercise number 1 asks us, why is it possible to talk about the measure, very important word, we're going to see the measure a lot, or length of line segment AB, but it's not possible to talk about the measure of line AB or ray AB? So think about this for a minute. Why can we talk about the measure of this line segment, but not of this line nor of that ray? Take a moment. Well, it's probably pretty obvious. I even have a little ruler here. But if I took my ruler up, rotated it, I could easily figure out then what the length of line segment AB is. So I could say, oh, AB, no symbol over the top of it, in this case would be about 73 millimeters. On the other hand, the problem with line AB gets into, where do I put the 0 mark? Right? I can't just put it at A because the line extends forever in two directions. Now, at least with a ray, I could say, well, maybe I'll put the 0 mark at point A. But then my issue is, where does the ray end? And the answer is it doesn't end anywhere, right? We think of space as extending infinitely. Now, don't get me wrong, I understand that you've got the idea of a finite universe and all of that. But in geometry, right, the idea is that this ray goes on forever, and the same thing with this line. You can probably summarize all of this by just simply saying rays and lines have infinite lengths, meaning that those lengths are so large we cannot even assign a number to them. Okay? Let's move on to the second exercise. Maybe. Maybe not. All right, exercise number 2. In the diagram below, all points shown are collinear. So E, F, and A all lie on the same line, which you might say to yourself, well, that's obvious. You've got a line drawn there, and you've got 3 points on it. But the key is with geometry, we want to make sure that we don't just look at a picture and take something for granted that we don't really know. You know, for all we know, there could be a slight bend at point F here, right? It could be just slightly bent so that they're not collinear. So I need to tell you that they are. Now, exercise letter A says give 3 different ways to name this line. 3 different ways to name this line. Let me give you one way to name it. All right, and there's actually many, many different ways. But remember, lines are dictated by any 2 points that lie on the line. So one thing I could say is I could say that this is line EF, right? Both E and F lie on the line, and then I put that double letter over it, or that double-ended arrow over it. I keep messing that one up, or at least messing up what I'm saying or how I'm referring to it. What I'd like you to do is take a moment and give me 2 other ways you can name this line, and try to use at least one of them that doesn't involve the 2 capital letters. Okay, well, again, we can pick any 2 points that lie on this line. For instance, you could say, well, we have line FA, right? And it doesn't matter what order you put these points in. So it could also be line AF. We could even have line EA. I know I'm listing way more than 3. And finally, and this is a little bit different, but you'll see it many times in this course, sometimes you'll see a little lowercase letter, as we do right over here. You'll see a little lowercase letter to name the line. That's going to be done more often when we're not really concerned about points that lie on the line, but we're concerned about the line overall. So it would be completely acceptable to also call this line M. Literally, line M. Let's take a look at letter B. Letter B says, give 2 ways to name the ray that starts at point A. Very important. It starts at point A and extends in the direction of point F. All right, why don't you give this a shot on your own? Okay, let's give 2 ways to name this ray. Well, if it starts at point A, then there is no getting around it. You've got to have the A come first. But then you could say that it's ray AF, Or, since these 3 points are collinear, you could also say that it's ray AE. All right? Both of those are the same ray, and that's very, very important to understand. I may have named them differently, but the plain fact is ray AF and ray AE both start at point A, and then they go infinitely in the direction of F. Okay? Take a moment now if you need to, and write down anything you have to on the screen, and then we'll move on to the next exercise. All right, let's go ahead. Let's talk about angles. Angles are going to be very, very important in geometry. Okay, so first, let's understand the definition of an angle. An angle, the geometric object created by two rays with a common starting point. Angles are symbolized by a single point, for instance, angle A, or a triple of points such as angle BAC, where the second letter is the vertex of the angle. All right? So, for instance, here we've got this angle. We could name it as angle A. We could name it angle CAB. We could name it angle BAC. We couldn't name it angle ABC. All right? We would never want to call this thing angle ABC simply because that second letter in our three-letter naming system has to be what's known as the vertex of the angle, where the two rays come together. Very, very critical. All right? Now let's talk about the measure of an angle. Okay? The measure of an angle is the amount of rotation needed to rotate one of the rays about their shared point so that it lies on top of the other ray. The measure of an angle is symbolized by putting a little m in front of the angle symbol. M angle A, M angle BAC. Now let's again get into measuring angles a little bit more because you've been doing this for so many years, so many years, and yet just make sure you really get it. The idea of measuring an angle is pretty simple, but it's based on the idea of a circle. Here we've got a protractor, right? And I'm going to make that protractor into the full circle that it truly is. And the idea is very, very simple. I'm going to make it much bigger in just a moment. There we go, right? The idea of a protractor or of an angle measurement is very simple. If we put the center of the circle, at the vertex of the angle, okay, and then we divide the circle up into 360 evenly divided spaces, okay, then all we're doing is measuring that many spaces. So for instance, this one happens to be a 40-degree angle. All right? It takes 40 degrees or 40 of these marks to rotate up the one ray so that it lies on top of the other ray. And it doesn't matter how big the angle is, in other words, how long the rays are, because we can adjust the size of the circle, and we will always, always, always divide that circle up into 360 evenly divided markings, okay? Which we call degrees. We'll learn about other ways to measure angles later on in this course, but we're going to stick with degrees mostly, all right? So let's get into a little bit more angle work. All right, exercise number 3. Consider the angle shown below. Letter A, give 3 acceptable names for this angle, and letter B, use your protractor to find the measure of this angle. All right, now I know we haven't done a lot of angle work yet in this course, but you've done angle work before in other courses. So what I'd like you to do is pause the video now, try to give 3 different names for this angle, and also try to measure it, and then we'll go through all the answers. All right, let's go through it. First, let's talk about the naming. Now, it may seem that this is somewhat trivial. How do you name an angle? But you would be surprised at how much this presents a difficulty for students. Time and time again, especially when we give you the name of an angle, students will get confused by it. So the first step is simply knowing how to name them. Let's take a look. All right, the easiest way to name this angle is simply by calling it angle D. And you might even ask yourself, why don't I always do that? And we're going to take a look why a little bit later on. But that's one of the ways of naming it, angle D. We could also name it angle FDE, and we could name it angle DF. The key in this three-letter naming system, again, is that the D lies as the second letter. It's at the vertex, so you can kind of see the two rays, ray ED and ray DF. All right. Now, let's take a look at the measurement of this angle. Now, this can always be a little bit tricky for students. And again, just like the measurements of length that we saw in the first lesson, if it's not perfect, that's okay. I'm probably not going to always get it perfect. But what I want to do is I want to put the vertex of the angle at the center of my protractor. And then I want to make sure I'm reading the right scale. But what I do is I look up on here, and it appears that it is at, let me maybe make this even a bit bigger so that you can really see it. It appears that it's at 38 degrees. Again, watch out. You don't want to think it's at 142 degrees, but hopefully everybody remembers that 90 degrees is a right angle, and we're nowhere near a right angle yet. For me, I've got this fancy schmancy way of being able to like rotate this thing up to here. You probably don't have that though on your protractor. Regardless though, what we see is that the measurement of angle D is 38 degrees. Don't forget to put that degree marker there. It's important. Whether your teacher takes off for it or not on a test, that's up to them. But for me, that degree marker is pretty important. All right, let me get rid of our compass, shrink it down a bit, throw it out of here. I love the fact that it bounces off the side of my board. All right, let me get out of the way for a second. Pause the video if you need to write down any of this, and then we'll move on to the next slide. Okay, let's move on. Exercise number 4. Answer the following questions based on the diagram shown below. Note that the ray symbols do not need to be attached to the line segments to still discuss angles. A ray extends forever, whether an arrow is drawn or not. Let me explain what I mean by that, right? I don't have little arrows at the end of ray DG or DF or DE. Because the plain fact is, the ray is there whether it's drawn or not, right? There is a set of points that extends from D through G forever, and likewise on these other two. I'm not going to always have those arrow marks there. Sometimes I will. But let's take a look at the rest of this particular problem. Letter A says find the measure of angle FDE. Letter B says find the measure of angle GDF, right? And then we'll talk about the other ones. But first, take a moment, use your protractor to find the measure of those two angles. All right, let's go through them. Bring it back into the screen. The measure of angle FDE. All right, I bring my protractor down. Okay, maybe make it a little, oh, I don't want to tilt it. Still don't want to tilt it. There it is, right? So the measure of angle FDE appears to be 36 degrees. 36 degrees. Now, the measure of the second angle, GDF, that's a little bit trickier because one of the rays isn't horizontal. So just like you had to do, I'm going to have to rotate my protractor in order to measure it. All right? And it's actually probably a little bit harder for me than it is for you. It doesn't really matter which one I use in the 0 mark, but again, I keep the center of my protractor, the center of my circle, right there at the vertex. And now I can see that it's past a 90-degree angle. In fact, it's at an angle of, now I can maybe shrink this thing down. I can't believe I just rotated it again. There we go. This is something you're not going to be able to do, but I can, and it's a nice feature. I'm now at a 108-degree angle. 108 degrees. And let's throw that away. All right, so hopefully you got your 36-degree angle and your 108-degree angle. Okay, let's take a look though at letters C and D in this problem. Letter C asks, why can neither of these angles measured in parts A and B be labeled as angle D? All right. Finally, it says, find the measure of angle GDE. How does its measure compare to those seen in A and B? Well, first, let's talk about letter C, because it is remarkably important. Why can neither angle FDE nor angle GDF be simply called angle D? We all like to save time. It's nice when we can refer to an angle by a single letter as opposed to 3 letters, but why can't we do that? Think about that for a moment. All right, let's talk about it. The plain fact is, the reason that you can't call either of those angles angle D is because you wouldn't know what angle we were referring to. Unfortunately, D, point D itself, is the vertex of more than one angle. And that's the key, right? And because it's the vertex of more than one angle, if we called anything angle D, we wouldn't know which angle we were referring to. In fact, it's not just the vertex of 2 angles, both of these two, it's actually the vertex of 3 angles. It's the vertex of angle FDE, of angle GDF, and of the final one that we're going to be measuring today, which is angle GDE. Take a moment right now and go ahead and measure that angle if you haven't done it already. All right, let's get the measure of angle GDE. Bring my protractor back down. Excellent. GDE is going to be all the way over here, and it's going to be at 140, somewhat around 143, 144. I'm going to call it 144 degrees. All right, let's bring this back down and get out of there. So what's this question about how does it compare to these 2 angles? So we saw that FDE was 36. We saw that GDF was 108. How does that 144 compare? Well, if it's not obvious, if we add the 108 to the 36, we get 144. And of course, that should make all the sense in the world. Because what we're doing is we're measuring rotation. And the plain fact is, if we're going to rotate 36 degrees to get this ray up to here, rotate 108 degrees to get this ray over to here, then to get this ray to rotate all the way over to here, we have 144 degrees. Angle measures add, just as segment measures also added in the last lesson. And that's going to be important, and we're going to use it a lot. It's probably fairly obvious to most of you, but we always want to make sure that you got that. In fact, the last problem we're going to do is going to emphasize that. Let me get out of the way just for a moment, though, in case you need to pause the video and write any of this down. All right, let's move on and do the last exercise. Let's take a look. Exercise number 5 says, the diagram shown is not drawn to scale. This is a pretty important piece of terminology. You should more or less assume that diagrams are not drawn to scale unless told otherwise, or unless you're told that you should be physically measuring something on the diagram. Obviously, if the diagram's not drawn to scale and we're asking you to measure something on the diagram, that would seem a little unfair. All right. But we're telling you this diagram's not drawn to scale, which means you shouldn't take out your protractor and try to answer the question using that. If the measure of angle CBA is x plus 7, CBA is x plus 7, the measure of angle DBC is 48, and the measure of angle DBA is 4x minus 20, then find the numerical value of the measure of angle DBA. All right, now, one thing that's rather nice about this problem is all those different angle measurements have been drawn and marked on the diagram. If they hadn't, we'd have to really kind of fish through what all of these things mean. All right. The question is, how do we find the measure of angle DBA? Now, obviously, this is going to involve a little bit of algebra, and some of you will already understand how to do it. So I'd like to pause for a minute and see who can work out this problem on their own. All right, let's work through it. Now, this really emphasizes what we were looking at in the last problem, which is the idea that angle measurements will add. In other words, the measurement, let me just do it this way, we'll do nice formal kind of work here. The measure of angle CBA, all right, that's this angle, plus the measure of angle DBC must be equal to the measure of angle DBA. All right? What this is going to allow us to do now, it's going to allow us to set up an equation where we can solve for the variable x. The measure of angle CBA, well, that's x plus 7. The measure of angle DBC is 48. And the measure of angle DBA is 4x minus 20. In a certain sense, this now ceases to be a geometry problem and becomes more or less purely algebraic. So let's go ahead and finish solving this equation pretty quickly. What we're going to have is we're going to have x plus 55. That almost looks like a plus, but not really. So let me get rid of it so you don't think it says x 455. Where's my plus? There it is. X plus 55 is 4x minus 20. All right, we can subtract an x from both sides. And since you're in geometry now and not algebra 1, I think we'll do 2 steps at once. So we're going to get 75 is equal to 5x. Divide both sides by 5. And x is going to be 15. Now, oh, wait a second. I had 4x minus x is 5x. That's a little bit silly. Let me get rid of that. I'm pretty sure that if I have 4 oranges and I subtract an orange, I don't have 5 oranges, although that would be kind of awesome. I have 3, so x isn't 15, x is 25. All right, 2 important lessons here. Important lesson number 1, everybody makes mistakes. Important lesson number 2, though, is make sure you finish the problem. It's very satisfying when we solve an equation and we get the value of x, but in this problem, they didn't say what is the value of x. They wanted the numerical value of the measure of dBA. Well, that's easy enough because the measure of dBA is going to be 4x minus 20. All right. Since we now know what the value of x is, we can substitute it in. X is 25, so we'll have 4 times 25 minus 20. 4 times 25 is 100, and 100 minus 20 all works out nicely. The measure of angle dBA is 80 degrees. All right. And that's it. Let me step aside, take a look at the work, pause the video if you need to, and then we'll wrap it up. Okay, let's move on to the last slide. In the lesson today, we looked at the ideas of lines, rays, and how rays come together in order to form angles. Angles are going to become increasingly important in this course. We're going to see them. They're going to be just as important as line segments. We saw that angles will add together in ways just like the lengths of segments will add together. We also saw how to name angles, and specifically, and very importantly, how to name them using 3 letters so we know exactly which angle we're talking about. Okay? Make sure, even though this is a relatively simple lesson, that you internalize this, that you practice with naming angles, with understanding what the measure of angles represent, all right, before moving on to more challenging work in geometry. For now, though, I'd like to thank you for joining me for another Common Core geometry lesson by eMATHinstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.